Hello, in this lecture we will find the radius of a circle enclosed in a triangle. We have triangle ABC with side AB that equals to 4 units, side BC equals to 3 units, and the side AC of triangle ABC equals to 5 units. And we know that the area of triangle ABC equals to 6 units squared, and inside the triangle we have a circle, and we want to find the radius of this circle. Okay, let's call the center of this circle O. So point O is the center of this circle, and let's call the touching point between side AB of the triangle to the circle N, or we can say that side AB of the triangle is tangent to the circle at point N. Point N is the point of contact between side AB of the triangle and the circle. In the same way, we will call the touching point between side BC of the triangle and the circle M, or we can say that side BC of the triangle is tangent to the circle at point M. And let's call the touching point between side AC of the triangle and the circle P. So side AC of triangle ABC is tangent to the circle at point P. Okay, now let's connect together points O and N by a straight line. Actually, line segment NO is the radius of this circle, because it starts from the center of the circle and ends at point N, that is a point on the circle itself. For that reason, line segment NO is defined as the radius of this circle. I will mark it as small r. In the same way, we will connect together by a straight line points O and M. And again, line segment OM is the radius of this circle, because it starts from the center of the circle, that is to say point O, and ends at point M, that is a point on the circle itself. For that reason, line segment OM is defined as the radius of this circle. And in the same way, we'll connect together points O and P together by a straight line. And again, line segment OP is the radius of this circle for the same reason, because line segment OP starts from the center of the circle, that is to say from point O, and ends at point P, that is a point on the circle itself. For that reason, line segment OP is the radius of this circle. I marked it as small r. In general, any line segment that is inside the circle and starts from the center of the circle and ends at any point on the circle itself is defined as the radius of the circle. For that reason, we have actually three radiuses that actually satisfies this definition of the radius of a circle. All of them start from the center of the circle, and all of them ends at any point on the circle itself. For that reason, they defined those three line segments defined as the radiuses of the circle, of this circle. Okay, now we have actually rule number 1 that states in any circle a radius and the tangent to that radius are perpendicular to each other. Okay, I will read again rule number 1. Rule number 1 states that in any circle a radius and the tangent to that radius are perpendicular to each other. So actually, if we have a radius, let's call it R, and if we have tangent to that radius, let's call it T, then the radius is perpendicular to its tangent T. That is to say, this angle equals to 90 degrees and this angle also equals to 90 degrees. So in any circle, a radius and the tangent to that radius are perpendicular to each other. Okay, for that reason this angle is 90 degrees and also this angle is 90 degrees. Okay, so actually we can implement rule number 1 in our circle because we have 3 radiuses and 3 tangents to that radiuses. We have line segment NO, that is the radius of this circle, and we have side AB that is tangent to the radius at point N. For that reason, according to rule number 1, the radius is perpendicular to its tangent. That is to say, angle ONA equals to 90 degrees, and also angle ONB equals to 90 degrees. Okay? Because the radius is perpendicular to its tangent. We have radius and we have the tangent to this radius, and the radius is perpendicular to its tangent. That is to say, this angle is 90 degrees and also this angle equals to 90 degrees. Okay? And for the same reason, line segment OM is the radius of this circle, and we have side BC of the triangle that is tangent to the radius at point M. For that reason, according to rule number 1, angle OMB will be equal to 90 degrees, and also angle OMC will be equal to 90 degrees, because the radius is perpendicular to its tangent. We have line segment OM that is the radius, and we have tangent to that radius that is side BC of the triangle. For that reason, the radius is perpendicular to its tangent. That is to say, this angle is 90 degrees and this angle is also 90 degrees. Okay, and for the same reason, line segment OP, that is the radius of this circle, is perpendicular to its tangent, that is side AC of the triangle. So the radius is perpendicular to its tangent AC. So angle OPA equals to 90 degrees, and angle OPC also equals to 90 degrees, because in any circle a radius and the tangent to that radius are perpendicular to each other. That is to say, this angle is 90 degrees and this angle is also equals to 90 degrees. Okay? In the next step, as you know, the area of any triangle equals to the base of the triangle times the height to the base all divided by 2. Okay, this is the area of a triangle. Okay, the area of any triangle equals to the base of the triangle times the height to the base, all divided by 2. Okay, or instead of area, I will write down the capital letter A. It is the abbreviation for area. A equals to the base of the triangle times the height to the base all divided by 2. This is the area of any triangle. The base times the height to the base divided by 2 equals to the area of a triangle. Okay, the base times the height to the base divided by 2 equals to the area of any triangle. Okay, in the next step we will connect together by a straight line points O and B. And we will also connect together points O and C by a straight line. So actually in triangle BOC, in the green triangle BOC, in the green triangle BOC, actually the area of the green triangle BOC equals, A is abbreviation of area, triangle BOC. The area of the triangle BOC equals to the base of the triangle, that is 3 units according to what is given in the question. So it is 3 units times the height to the base. You should remember that the height to the base creates 90 degrees with the base. Actually the radius creates 90 degrees with the base. For that reason the height of triangle BOC equals to the radius of the circle. So it is 3 times the radius, all divided by 2. Okay, so the area of the green triangle equals to the base, that is 3 units, times the height to the base. The height to the base is the radius of the circle, because it creates 90 degrees with the base. For that reason the radius of this circle equals to the height of triangle BOC, the green triangle, all divided by 2 is the area of the green triangle BOC. So 3 times the radius divided by 2 equals to the area of the green triangle. Or in other words, 3 over 2 is 1.5. 1.5 R equals to the area of the green triangle. Okay, so the area of the green triangle equals to 1.5 times the radius of the circle. Okay, in the same way we will calculate the area. Before that we will connect together points O and A by a straight line. and then we will calculate the area of triangle AOC, or we will calculate the area of the yellow triangle. So actually the area of the yellow triangle AOC equals to the base of the triangle AOC, that is 5 units according to what is given us in the question. So it is 5 units, that is the base of triangle AOC, times the height of triangle, the yellow triangle AOC. The height of triangle AOC, the yellow triangle, is the radius, because the radius creates 90 degrees with the base. Okay, for that reason the radius is the height of the yellow triangle. So it is 5 times the radius, all divided by 2. Okay, again, the area of the yellow triangle, triangle AOC, equals to the base of the triangle, that is 5 units, times the height of the yellow triangle, that actually equals to the radius of the circle, all divided by 2. So it is 5 times the radius of the circle divided by 2, or in other words, 5 over 2 is 2.5. Or in total we will get that the area of the yellow triangle equals to 2.5 times the radius of the circle. Okay, so the area of the yellow triangle equals to 2.5 times the radius of the circle. Okay, and in the same way we will calculate the area of triangle AOB. So the orange triangle, that is triangle AOB, actually the area of the orange triangle will be equal to the base of the orange triangle, that is actually the base of the orange triangle is actually 4 units. It is given us in the question, times the height of the orange triangle. The height is actually the radius of this circle, because of the fact that the radius of this circle creates 90 degrees with the base. This angle is 90 degrees and this angle is also 90 degrees. So it is 4 times the radius, all divided by 2. Okay, so the area of the orange triangle, triangle AOB, equals to the base of the triangle, that is 4, according to what was given us in the question. So the base is 4 times the height of the orange triangle, that is actually the radius, because the radius creates 90 degrees with the base. This angle is 90 degrees and this angle is also 90 degrees, all divided by 2. So it is 4 times r divided by 2. 4 over 2 is 2. Okay, so in total we got that the area of the orange triangle equals to 2 times the radius of the circle. Okay, but the area of the big triangle, triangle ABC, equals to the sum of the areas of the yellow triangle plus the area of the green triangle plus the area of the orange triangle. Okay, so it is actually equals to the area of the green triangle, that is actually BOC, plus the area of the yellow triangle, that is actually triangle AOC, plus the area of the orange triangle, that is actually triangle AOB. So as you can see from the drawing, from the picture, the area of the big triangle, triangle ABC, equals to the sum of the areas of the three triangles the triangle ABC contains. So the area of triangle ABC equals to the area of the green triangle plus the area of the yellow triangle plus the area of the orange triangle. Okay, so that will be equation number 1. But according to what is given us in the question, we do know that the area of the big triangle ABC equals to 6 units squared. It is given us in the question. So actually we can substitute the area of the big triangle ABC by 6 units squared, because the area of triangle ABC equals to 6 units squared. Okay, so we'll substitute the area of the triangle, the big triangle ABC by 6, and it is equals to the area of the green triangle, that is actually 1.5 times the radius, plus the area of the yellow triangle, that equals to 2.5 times the radius, plus the area of the orange triangle, that is equals to 2 times the radius. Okay, again, the area of the big triangle ABC equals to 6 units. It is given us in the question. We know from the question itself that the area of the big triangle ABC equals to 6 units squared. So we can substitute the area of triangle ABC by 6. And we have already calculated the area of the green triangle, that is 1.5 times the radius, plus the area of the yellow triangle, that is 2.5 times the radius, plus the area of the orange triangle, that equals to 2 times the radius. So in total, the area of the big triangle ABC equals to the sum of the areas of the green triangle plus the area of the yellow triangle plus the area of the orange triangle. Okay, if you can see from the picture, the area of the big triangle, triangle ABC, equals to the sum of the areas of the yellow triangle plus the area of the green triangle plus the area of the orange triangle. Okay, so 1.5r plus 2.5r equals to 4r, and 4r plus 2r equals to 6r. So in this side of the equation we have 6 times r. Okay, so in total we will get that 6 units squared equals to 6 times the radius. Okay, so in total we got that 6 units squared equals to 6 times the radius. We can divide equation number 1 by 6. We'll get that the radius of the circle equals to 1 unit. Okay, we divided the equation by 6. We got that the radius of this circle equals to 1 unit. Okay, now I will summarize the lecture. Okay. So actually we wanted to find out the radius of a circle that is inside the triangle ABC. The circle inscribed inside triangle ABC, and we actually know that side AB of triangle ABC equals to 4 units, side BC of triangle ABC equals to 3 units, and side AC of the triangle equals to 5 units. And we also know that the area of the big triangle ABC equals to 6 units squared. And we have to find the radius of the circle inscribed in triangle ABC. Okay, first of all, we defined the center of the circle as point O, and then we defined that side AB is tangent to the circle at point N, side BC of triangle ABC is tangent to the circle at point M, and side AC of triangle ABC is tangent to the circle at point P. Okay, and in the next step we connected points O and N together by a straight line. Also points O and M we connected by a straight line, and we connected by a straight line also points O and P. Actually, all these line segments ON, OM and OP are the radiuses of this circle. Why? Because they start from the center of the circle and they end at any point on the circle itself. For that reason, they are defined as the radiuses of this circle, because any line segment inside a circle that starts from the center of the circle and ends at any point in the circle itself, it is defined as the radius of the circle. For that reason, those 3 line segments, ON, OM and OP, are defined as the radiuses of this circle, because they start from the center of the point, and they start from the center of the circle and ends at any point on the circle itself. For that reason, they are the radiuses of this circle. Okay, then we actually have rule number 1 that states that in any circle a radius and the tangent to that radius are perpendicular to each other. So if we have a radius, we defined it as R, and we have tangent to that radius, then the radius is perpendicular to the tangent. That is to say, this angle is 90 degrees and this angle is also 90 degrees. So in any circle, a radius and the tangent to that radius are perpendicular to each other. Okay, so actually we can implement this rule number 1, in our circle, because we have here 3 radiuses and we have 3 tangents to that radiuses. For example, line segment ON is the radius of this circle, and we have tangent AB to this radius. For that reason, according to rule number 1, the radius is perpendicular to its tangent. That is to say, angle ONB equals to 90 degrees, and also angle ONA equals to 90 degrees. And for the same reason, we have radius, line segment OM is the radius of the circle, and we have tangent to this radius. Side BC of the triangle is tangent to the radius at point M. For this, that reason, according to rule number 1, the radius is perpendicular to its tangent. That is to say, angle OMB equals to 90 degrees, and also angle OMC equals to 90 degrees. And also, we have line segment OP, that is the radius of this circle, and we have also side AC, that is tangent to the radius at point P. For that reason, according to rule number 1, the radius is perpendicular to its tangent. That is to say, angle OPC equals to 90 degrees, and also angle OPA equals to 90 degrees. Okay. Then we connected points O and B together, and also we connected points O and A together by a straight line. And then we created the green triangle. Triangle BOC is the green triangle. And in general, we know that the area of any triangle equals to the base of the triangle times the height to the base divided by 2. Or A, that is the abbreviation for area, equals to the base of the triangle times the height to the base divided by 2. Okay, so we can use this formula to calculate the area of the green triangle, because the area of the green triangle will be equal to the base of the triangle, that is 3 units, times the height to the base, that is the radius. The radius of this circle is the height to the base of the green triangle, because it creates 90 degrees with the base. So actually the area of the green triangle equals to the base of the green triangle, that is 3 units, times the height, that is the radius, divided by 2. Or the area of the green triangle equals to 1.5 times the radius. Okay, then we connected points O and A together by a straight line, and we created the yellow triangle. Triangle AOC is the yellow triangle, and the area of the yellow triangle equals to the base of the triangle, that is 5 units, times the height to the base, that is the radius of this circle, all divided by 2. Or the area of the yellow triangle equals to 2.5 times the radius. Okay? And then we calculated the area of the orange triangle, that is also equals to the base of the triangle. The orange triangle, that is 4 units, times the height of the triangle, that is the radius, all divided by 2. So the area of the orange triangle equals to 2 times the radius. So, but we know that in total, the area of the big triangle ABC equals to the sum of the areas of the yellow triangle plus the area of the green triangle plus the area of the orange triangle. So in total, we can say that the area of the big triangle ABC equals to the area of the green triangle plus the area of the yellow triangle plus the area of the orange triangle, or in total. But we know from the question itself that the area of the big triangle in BC equals to 6 units squared, and we already calculated the areas of the green triangle, the yellow triangle, and the orange triangle. We know that the area of the green triangle is 1.5 times the radius. The area of the area of the green triangle equals to 1.5 times the radius. The area of the yellow triangle equals to 2.5 times the radius, and the area of the orange triangle equals to 2 times the radius. So in total, the area of the big triangle ABC equals to the sum of the areas of the green triangle, the yellow triangle, and the orange triangle. Or we can say that 6 equals to 6 times the radius, because 1.5 times r plus 2.5 times the radius plus 2 times the radius equals to 6 times the radius, and all equals to 6 units squared. We divided equation number 1 by 6, and we got that the radius of this circle equals to 1 unit. Okay, so the answer to the question is that the radius of the circle inscribed in triangle ABC equals to 1 unit. Okay, thank you very much.